Hello and welcome to part 3 of our chapter 7 videos about normal distribution. Hopefully if you went ahead and worked out this practice problem, we're going to go over it. So first, our practice problem states that we want to know the probability of someone giving birth less than 40 weeks. So in the top part here, we know that uncomplicated human pregnancies from conception to birth is approximately normally distributed, right? They're normally distributed with a mean of 39 weeks and a standard deviation of 2 weeks. So we're going to state, we have our statement of the problem, right? So this is step 1 of our statement of the problem, which is what is the probability of X being less than 40 weeks. It's notated by X distributed as a normal distribution of a mean of 39 weeks, mu, and a standard deviation of 2 weeks. So notice here that we're using n for normally distributed. Back in chapter 6 we had a b, it's for binomial distributions. And so when you see n or b, that's going to tell you the difference between whether this is a normally distributed problem or whether you're using binomial distribution calculation going forward. So if you remember back in our previous slide here, determining normal probabilities, we're first going to state the problem. Then we're going to standardize the value using a z-score. We're going to sketch and shave the curve, and then use table B to determine the probability. So this first part here, we stated our problem, step 1. Step 2, we're going to learn about how we standardize normal z variables. So a standard normal variable, which is a normal random variable with a mu of 0 and a standard deviation of 0. Right, this is what was basically used in table B. This is how this table B is kind of set up, is based on the standard normal. What we're going to do is we're going to calculate what's called z variables. It's notated as z is distributed as a normal distribution of 0 and 1, where we use table B to look up cumulative probabilities, page 541 in your book. So here we go, step 2. So now we're going to actually standardize the problem getting our z-score. So to standardize, we're going to subtract our mu and then divide by the standard deviation. This is set up like this. So our z, highly recommend when we're doing a z-score or any problem, write what you're equaling. This is going to equal a z-score, so our z is going to equal our x minus mu divided by the standard deviation. The z-score tells us how the number of standard deviation units the value falls above or below the mean. So for example, we have our value of 40 from our x normally distributed as a normal distribution of remember this is mu, standard deviation, so a mu of 39 weeks, standard deviation of 2 weeks, would be set up like this. Our z equals 40, remember, so 40 is our x, minus our mu, divided by the standard deviation of 2. 40 minus 39 is 1, 1 over 2 is 0.5. So here we have 0.5. Another thing I highly recommend all students to do is, this is great. A lot of people can do this part, but then they don't understand what this value is right here. And so once again, I put this equals a z-score, or equals z. Write down what that equals, right? So that's a z-score. And if you know it's a z-score, because that's what you're solving for, you know that you have to go now to table B. You can't just leave it as a z-score, because the z-score just tells us, remember, the z-score tells you how the number of standard deviation units the value falls above or below the mean. If it fell exactly on 1 or 2 or 3, it's a little easier to calculate going forward. But if it's not, doesn't land exactly on those, and we're not trying to find between, right, we're trying to find cumulative probability, then we have to rewrite this out that we're finding a z-score and we're going to table B. So when we go to table B in the back, you'll notice the portion of table B is highlighted. This is a z value of 1.96. So the way table B is set up, 100%, the hardest part about this entire chapter here is understanding this table in the back. So if we were to find, if we had z equals 1.96 as an example, right? What we do is you see this column here, the z tenths, you'll notice it increasing in value. And it's 1.9, right? So it's 1.9 right there. And then the Z100s go this way. So this would be, this value right here would be 1.90. And this one's 1.91, 1.92. And then when you get all the way here, this value is 1.96, right? And that's what we're looking for, 1.96. So 1.9 in the tenths go over to the hundredths is 0.06, right? This is 1.96, and we'll see that a z value of 1.96 gives you 0.9750, which you could say is 97.5%. You can do this with anything. The hardest part, or the people I see most people mess up, is they'll get a z value and they'll stop there. If you realize if you write this equals z after writing it down, you'll know you have to go to table B. And when you go to table B, you find your z tenths, right, which is going to be this part of the problem, and then you follow it over to the Z100ths and find your value, and that will give you the percentage. So when we use table B now for our problem, it's going to look something like this. So our probability of z is less than or greater to 0.5, which is going to equal 0.6915. So once again, you would go over. So remember, there's always an implied 0 here, so this would be your tenths. And then you're going to go all the way over to your hundredths. So our tenths of 0.5 with our hundredths of 0.00 gives us this value right here. Fancy highlighting it. And so that would tell us the probability of a mother who has their baby with less than 40 weeks. All right, because our x was 40, we got a z value of 0.05, cumulative probability of 0.6915. Remember, table B is always going to tell us from this value we find the z-score in the shaded part to the left. If you look at the very first thing in table B, any probability you find, wherever it is going to be that value shaded to the left. So if you ever find a z-score of 0, always know that 0, right, is going to be the very middle. And that's going to be that value shaded to the left, which is always going to be 50% or 0.5. So moving on. So now if you want to find the probability between 2 points. So if you look at like part B here, right, that's kind of what we did. If you want to find the probability between 2 points, find the probability of A is less than or equal to Z, which is less than or equal to B. So you find the probability of B minus A. And that's what it's doing here, right? If you find the probability of B, subtract from the probability of A, right? It's finding all those values from there to the left and there to the left. You subtract those out from each other, right? So we're taking this part away, and then you're left with the probabilities of the values between. So B and A are going to be a value, and you're going to plug those values into your z-score formula. So that'd be like z is equal to x minus mu over the standard deviation, where this value of B is going to be your x there, and same thing with A is going to be your value of x. You're going to find that z-score, and then you subtract the z-scores from each other to find the probability. Or you subtract the probabilities from each other, not the z-scores, subtract the probabilities from each other to find the in-between probabilities between 2 points. So now, part 3 here is finding all values corresponding to normal probabilities. So, once again, you're going to state the problem, make sure the problem is stated. You're going to use table B to look up your z percentiles values, sketch it, unstandardize it with this formula. So with this formula here, notice that you're solving for a value of x. And this is going to be to solve for x. So say we want to know what is, the top 90th percentile of male babies who are born, their weight. So we want to find what weight value would be considered the top 10%. All right, so this would be a Z percentile that we're looking for to find a value of X. Go into looking up our Z percentile values to show you what this looks like. So you're going to use table B to look up a Z percentile value, i.e. the Z score for the probability in the question. Remember, when you find a Z score, we're going to go to table B and now find the probability. This one's kind of working backwards. We're given a Z percentile, so we're already looking at the percentile, and we're going to find the Z score that corresponds to that probability. So you're going to look inside the table for the entry closest to the associated cumulative probability, then trace the Z score to the row and column labels. So when we say entry to the closest associated cumulative probability, on some problems this can change a little bit depending on where the value actually lies. We're going to enforce to keep everyone consistent, because just to keep everyone on the same page and everything fair, firm, consistent, we're going to use what's the Price is Right rules. Price is Right rules, right? R-I-G-H-T, that's spell. So you're going to use the Price is Right rules. And the Price is Right rule says you're going to go to the value that's closest without going over. So we're going to go to the value that's the closest to our Z percentile without going over. This is going to keep everyone consistent and on the same page. There might be some times where you'll see a value over what we're looking for might be closer than the one underneath it. But we're going to go to the value that's the closest without going over. And this is represented on the practice problems in length, so you can see that going forward. Knowing that, then we're going to trace the Z-score to the row and column and get our actual thing. So suppose you wanted the 97.5% tile Z-score. You look inside a table for 0.9750, then trace the Z-score to the margin. So this is very similar to what we did before, remember? So if you see here, we have 0.9750. This is our Z percentile, which is always donated Z with a little p underneath it, the p under the percentile. So if you notice you see a Z underscore p, we're going to be looking for a percentile. And the percentile is going to then lead us to the Z score. So if you think about it, we're going to find the percentile and lead us to the Z score. So the percentile of 0.9750, we're going to go over, which is going to be our tenths, which is 1.9. And then if you want, you can think of it, you can add 0.062, which would equal 1.96, or if you just know that this value here is going to go there on the value, so it's 1.96. So when we look up a Z percentile, again, that's a Z underscore P, so if you see that you're looking for a percentile of a Z score, you're going to find the percentile of 0.9750, then you're going to trace that back to the Z score margins, and that's going to be 1.9, then you go to your hundredths of 0.06. Once you do that, now you have your Z percentile score. So the Z would be 0.9750. This is how it would be represented. So you know Z underscore, and this is the percentile, is going to equal 1.96. That is how you use Z percentiles to find the Z score. And then what we're going to do is we're going to go back here, and this is what we just talked about, is finding this Z percentile score. So now we found a Z percentile score that corresponds to something. We're going to then multiply it by the standard deviation, add it to the mean, and this is going to give us our X value of what we're looking for. This X value being, you know, maybe what is the height or weight of babies that is in the top 10%. You would have to look up the exact values going forward. And so found out what the Z percentile is here. On the next part of the video, we're going to be picking it back up and taking this a little bit further. So I'll see you all in the next video.